Oh, welcome back to math today. What we're going to focus on today is to be able to understand the volume of prisms. We're now going to take up the space inside of shapes. Write this down with today's date and page number. All right, for your warm-up, I want you to find the area of two things. One, which we just did recently, another one you did last year to see if you can figure it out. Let me help you out a little bit with this. Number one, area of a rectangle is area equals length width. And for a circle, it's pi, or 3.14, radius squared. Come back when you got them both. So here are the answers you should have received. I know we haven't done anything with area of circles, but it's good to see if you could be able to just watch a formula, plug and chug it out. So r squared would have been half of the diameter, which is 4 for number 2. 4 squared is 16. Multiply that by pi. Okay, if you got those both right, give yourself a nice pat on the back. All right, so what again is volume? Volume is the number of cubic units needed to fill a space. So how much area you can fill up inside of something. Write this down before moving on. So let's kind of explain what I mean here. Let's say we were looking at a container that's 3 centimeters by 5 centimeters by 2 centimeters. If we were to look at it in different layers, it would take 5 times 2 centimeter cubes to cover the bottom layer of that shape. So if you did 5 times 2, that gives you 10. But if you had 3 layers of it, it would be 10, plus another 10, plus another 10, which would give you 30 cubic centimeters. So you could just simply do length times width times this new step, which is the height. And that's how you get 30 cubic centimeters. You don't have to write this down unless you want to. Let me show you what I mean. So here's our first problem that we're going to do together. And you're going to write this down in your notebook. You could probably draw that rectangular prism in as well. So as you can see, the new formula is length times width times height. So the length is 26, width is 11, and the height, 13. And all you have to do with those three things is multiply them together. Obviously, this is why I let you use your calculator, because these are larger numbers. 26 times 11 times 13 gives you a volume of 3,718 inches cubed. And remember, this is the 3 steps I want to see written in your notebook, on your homework, on a quiz, on a test, anywhere. Formula, plug, and chug. Write those down before moving on. All right, now that you got the process down, go ahead and do 1, 2, and 3. 8, 9, and 10 are there if you want to challenge yourself and do them. Just remember, you always start out with volume with the formula length times width times height. Volume equals length times width times height. Volume equals length times width times height. Plug, chug. Come back to see what you get. And here are the answers you should have received in the format that it should look. And remember, you label it with the label centimeters, inches, and feet, and it's cubed. So you can't tell because it was sloppy, so I'll fix it. Number 3 is actually feet cubed there. Okay, give yourself a high five if you got these all right. Now, when you have a rectangular base, it's pretty easy, but sometimes you're going to get these bases that have triangles. Well, really, the volume of any prism is technically volume equals base with a capital B times height, which is just the height of a shape. So sometimes the prism is going to have a different base. Let's go through a couple of what I mean by this phrase here. All right, so here we have a triangular prism. We got to find out how much stuff you can fit inside that. So the formula is base times height. But as you can see, base is whatever the specific base is of the shape. Now the shape of this base is a triangle. So we have to first find the base of that triangle, then multiply it by the height. So the first step is finding out, remembering how to find the area of a triangle. Remember, area equals 1/2 times base times height. So we have the 1/2, the base is 3.9, and the height is 1.3. That's how we put that together. When you multiply those three things together, let me get out my, and I go ahead and I multiply those three numbers together, I get a decimal 2.535. Then all I have to do is multiply that by this height over here to make it a three-dimensional shape. And when I multiply that number by 4, I get 10.14 meters cubed. So you got to find the base first and then just multiply it by the height. Write this down before moving on. We'll try one more before we're done. All right, so here's another one with a triangular base. Remember the formula is first volume equals base times height. So the base in this example is a triangle, so it's 1/2 times base times height. So 1/2, obviously, the base is 6.5, and the height, we have an arrow over here to try to show that this is 7 feet. So when you multiply 6.5, you can't see me doing this, but I'm using my calculator, 6.5 times 7 times 0.5, you get 22.75, and that's the base. But now we have to multiply it with that height, which we can see here is 6 feet. So when we multiply those together, that's how you get 136.5 feet cubed. Plug, chug, and once your work is all written out, looks good. So your turn, I want you to do these top three, 4, 5, and 6. So remember, volume equals base times height. Volume equals base times height. And volume equals base times height. And remember, all three of these have a base that's a triangle. So the base is going to equal 1/2 times base times height. Okay, good luck. Come back when you're done. We'll see how you did. All right, here are the answers you get after plugging and chugging. So number 4, 351 meters cubed. Number 5, 320 feet cubed. Number 6, 2,500 decimeters cubed. Decimeters. That's the answers you should have gotten for those. If you got all three right, come on over and give me a high five. Now sometimes you'll get word problems like this where you're trying to figure out what kind of shape you actually are looking at. So suppose a facial tissue company ships 16 cubic tissue boxes in each case. What are the possible dimensions for each case of the tissue box? First thing we have to be able to do is understand the problem. Well, the answer is asking, will there be different possible dimensions for a case to put 16 cubic boxes in there? So the two important things we need to know is there's 16 tissues in each case, and the boxes are cubes. So first thing you need to do is make a plan. We're basically going to be looking to find models that have a product that has 3 factors, and those 3 factors have to equal 16. Well, one possible way it could be is it could be 1 times 8. I'm sorry, 1 as its height, 1 as its width, and 16 across. So you could have 1 times 1 times 16. You could have 1, 2, 3, 4, 4 across, 4 high, 1 deep. 4 times 4 is 16 times 1 would work. You could have one that's 2 deep by 2 high by 1, 2, 3, 4. And the other one we have here is 1 deep times 2 high times 8. So there's many different ways that you could fit that box. Those are the different ways that you could have made this box shape to send the tissues. So for practice, go ahead and do number 7. Come back when you're done. All right, so here are the possible ways you could have boxed up 10 cubic boxes of toys. There's really only 2. 1 times 1 times 10, or 1 times 2 times 5. Those are really the only 2 ways, and hopefully you got both of them on your own. If you did, high five to yourself. Nice job. All right, go ahead and complete your box of thought. These two questions here. Come back with full sentences explaining and describing the two questions. And here is your quiz. 3 questions finding the volume of 3 different figures. Well, don't forget to write the formula, the plug, and the chug. See you when you're done.